I'm really delighted to present our first speaker. Sangwoo, please take it away.
Thanks. Hi, thank you for coming for my talk. So I'm Sangwoo, Shim. I'm working as a CTO at MakinaRocks. So today I will talk about the way we are using Jupyter as a key integrator for our MLOps, MakinaRocks Runway. Okay, so let me talk a little bit about MakinaRocks. We make MLOps, industrial solutions. So we are about 100 people in Seoul and San Jose in US, and we are a Series B company. And we were listed as on Advanced Manufacturing 50 list by CB Insights, and was selected as a technology pioneers by World Economic Forum. So MLOps, like machine learning operation, has become quite a buzzword as the application aspect of AI gets more attention, right? So here's a Google trend result of the MLOps since 2014, okay? It's increasing, of course, yeah. So, and let me just, Kubernetes actually comes up here. And of course, Project Jupyter is here. And also TensorFlow here. And this is just a hidden technical debt in machine learning system. This is important, like a NIPS paper by Google that basically says that there are many things to build a working ML system other than ML model itself. Okay, and I think that the emergence of this paper actually was a very important event for an MLOps. And PyTorch here, Transformer, GPT, MLflow, GPT-3, and also the initiative of data-centric AI is here. We should also talk a lot about importance of MLOps than ChatGPT here, right? So I would say that the importance of the MLOps is recognized more as we are understanding more and more about the real-life benefit of AI. Okay. So the thing is, like, different projects have different requirements, right? And in turn, have different definition on what would be the right MLOps for them, okay? So for example, for a machine vision project, integrating data labeling tools would be an important component when building their MLOps system, right? But at MakinaRocks, we have actually carried out many different projects with many different requirements, mainly in manufacturing and energy industry. So usually something like anomaly detections, optimal control problems, combinatorial optimization problem, and forecasting problems. So when we decide to make our MLOps system, we naturally focused on common ingredients across all these requirements, which are these. So, so our focus is helping data scientists make training pipeline for the operation, which is not always an easy task for data scientists. And also, secondly, improving model observability. So if I have a trained model around, I want to know how the model was trained, basically, which means what was the training code, right? And what was the model architecture, and what was the environment in which the model was trained, and what data set was used. Who trained this model, right? Those everything. So what kind of parameters were used, right? And also, if I have all the information, can I train a new model, right? With new data set and new set of parameters without asking the author, okay? Then we can improve a buzz vector tremendously, right? So also, next thing is various model strategies. So you may want to provide an inference service through REST API, for example, batch type inference service or real-time inference service, right? And look, behind your inference endpoint, you might want to carry out the A/B testing, load balancers, horizontal scalings, right? All without involving lots of complex configurations, okay? And also, of course, performance monitoring, right? So comparing accuracies among models, monitoring inference throughputs and latencies, type of thing. And finally, like interoperability. So can I still use my beloved data warehouse or experiment trackers like MLflow, 1DBs, right? So yeah, so today I'll talk about those 4 things. And the first would be the data scientists in MLOps. For MLOps, usually I would say that data scientists will have additional roles, and that actually there are also challenges that comes with the new roles, right? So yeah, so that will be my first. I want to discuss the roles and challenges of data scientists within MLOps context, and how do we streamline the pipeline creation for data scientists, and how do we manage models at scale. And I will also show a demo of our system at that point. And finally, I would like to share our belief for the future of MLOps. Okay. Okay. So this is a typical flow for developing ML models, right? We all know and love. So we prepare, training data, validation data, test data, right? Then we carry out the model training with the training and validation data, right? And also with training code, model architecture, and sometimes implicitly with execution environment for running these codes, and a parameter for carrying out the training, right? And maybe some of them are version controlled, right? And with this, we come up with a trained model, and sometimes implicitly the execution environment to run that model, right? Then what we do is we throw the test data into this, and we come up with a metric. Of course, we need a code for the metric too, right? Then log the experiment to the experiment management, and we just keep doing this, right? Until we get a satisfactory result, right? So, traditionally, data scientists then deliver this trained model, right? And so sometimes we do, or sometimes we don't deliver the execution environment, right? So then software engineers use the trained model to implement the product or service. But not the machine learning models usually need to get updated, right, with new data and parameters, right? So to retrain the model, so software engineers need to contact the author of the model and then ask her or him to retain the model, right? And well, this approach works, but this approach actually can slow down the entire development loop or deployment loop for the applications, right? So, to establish a more efficient operation, data scientists are requested to provide an entire pipeline here that can produce trained models instead of just throwing out a trained model, okay? Then with that training pipeline, operator can run the pipeline with the new data, right? And the new parameters to obtain a new trained model here without involvement of the data scientist because we have the training pipeline at hand. And also then the operator in MLOps has a control for the trained model interface. So MLOps also provides model development strategies for making serving service, for example, for web app. The serving service may provide REST API for the applications, or for an embedded application, they may produce some kind of binary block for that can be run with the microprocessors, right? Then the model can be updated without changing the application code, right? And without involving, most importantly, the data scientists. So this is all good, but like introducing MLOps can impose additional burdens to data scientists, right? Because you guys need to compose the data pipeline now, right? So data scientists are already fluent in, Python and machine learning libraries, so this is not really difficult to grasp. But they also need to learn the container-related skill sets, including Docker, Kubernetes, for handing out their execution environment, right? And also should be able to write a pipeline definition, like user candidates or Argo workflow, Airflow, and Kubeflow, and Louis, and others. So compared to the past, the data scientist role got expanded a lot, right? So to our belief, but to carry out an ML project successfully, data scientists need to spend more time in analysis and modeling, okay? That's our belief. So how can we help them out, right? So our approach was to add pipeline composition capability to our beloved JupyterLab, okay? So let's quickly review how JupyterLab works, right? So if you write a program with Python kernel in JupyterLab, you get cells, right, for codes, and IPython kernel, with memory, right? So if you execute the cell 1, it will read from the memory, carry out the computation, and update the memory, right? And so you can quickly check your intermediate result at this point, right? This gives you flexibility in exploring the problem at hand. And you keep doing this, right, until you get a satisfactory result, right, which is blue here. But on the other hand, this flexibility sometimes comes with how can I say, insufficient robustness. Okay, so let's compare the cases where you execute these cells in this order, 1 to 3, versus executing cells in that order, 1, 3, 2, right? Then you will get red, green, and blue on the left scenario, but you will get something different intermediate and end result if you happen to have different execution order, right? But still, this is good for experiment, visualization, and tests, right? So our goal with MakinaRocks Link were we want to get the consistent execution result regardless of your execution order, okay? Or you can also say that we specify the execution order or dependencies among cells, okay? But we still want to retain the flexibility of JupyterLab, okay? So to achieve these contradictory goals, we introduced a subtype of a code cell, which is pipeline cell, okay? So you can assign execution dependencies among pipeline cells and attach per cell caches to every cells in the pipeline. Then when we run cell 3 here, its parent cells are run in the background first and fill its cache like this. So cell 1, calculate and fill its cache here. Cell 2, fill its cache, okay? Then the cell 3 takes the union of the cache memory, okay? And use that as an input and carry out the computation and update its cache, okay? But because these cells are still code cells, JupyterLab cell, right? So we copy the result of the cell cache back to the JupyterLab memory, okay? Then you still have flexibility to looking through an intermediate result to visualizing the data using the normal code cell like this, right? You just put an additional cell, which is not a pipeline cell, so you can just play with your IPython kernel memory, right? However, even if your Jupyter memory gets changed by normal cells, cache memory of the pipeline cells do not change, right? So yeah, that means if you have link extension and write your code using the pipeline cells, the order of execution doesn't matter because actual order sequence is determined by the dependencies in the pipeline, right? So yeah. And because you can figure out the independence of the cells pretty easily, because you have a basically directed acyclic graph, you can even parallelize the execution. And also because each cell has serialized its memory into its cache, you can also carry out per cell remote execution as well. So Link pipeline also has built-in like parameter injection ability. Also, when you once you successfully run your pipeline, you can also export your Link pipeline into Argo workflow pipeline, or like our pipeline definition that can you run out of the Jupyter. And by writing appropriate converters, we can basically support any other DAG-based pipeline like runners, like something like Airflow or other pipeline runners, right? So I think this makes MakinaRocks Link as a very good entry point to the MLOps for data scientists. Okay. So now I want to show you a demo of MakinaRocks Runway, our MLOps platform. So here, let me just log in. Yeah, and this is basically like sandbox environment that we use for the demos and tests. So I already made a JupyterCon project here. You can create a project, of course. Then it has like datasets management, like pipeline management. Oh, sorry about that. Perhaps I need to stop this. Oh, it doesn't mirror. Let me. Okay. How can I mirror this? Mirror. Yeah. Thanks. So, yeah. Sorry about that. Okay. So, yeah. I made a JupyterCon project already. So in the project, we have dataset management, pipeline management, and you can schedule the pipeline, model registries. You can carry out the stream and like API type of inference service. Also, you can attach the data source where you can like create your data set from. Okay, so for example, you can connect to your data source. Could be like database or object storage. Okay, then just put some credentials and connect, and you can connect to it. I already made a connection here to our like demo data set, which has on like real-time updates on the other side. So with this data source, you can actually carving out the trained data and validation data, right? And you can actually create the data set, for example, like, or you can just like create your data set from your local file or data source, or the inference result, or like object storage. And I already made a like data set. If I made a data set here, then actually this data set will appear as a Parquet file in your JupyterLab, like file system. Okay, so you can open, yeah, and let me just open a little Link instance here. So it has a built-in JupyterLab with, of course, our plugins. So take some time. Sure. So it has like data set. You have a trained data as a Parquet file, and this is the read-only, and is accessible by all members of the project, so that you can always take a look at the same thing. Okay. And I also checked out a demo notebook here. This is this. So if I click this, so as I said, like it has now we have like two type of cells. This is like normal cells, behaves exactly same as those of like JupyterLab, vanilla JupyterLab, and this cell with like slight purple background is a pipeline cell. Okay, so to make a pipeline cell is as easy as just like make a cell, make a normal cell, and just give a name, and like specify some, like dependencies, basically pick the parents, perhaps here, right? Then you get a new pipeline cell. So, and let's remove this guy. And then you can run this, right? Then it will automatically figure out which cells to run, right? And then like carry out the computations. This guy runs this cell in the background. And after it's finished, comes here. And, you know, this basically logs the trained model to our system, right? And then it has like cache properties. So if I run this, I don't need to run whole this thing again because I already have an input here. So if I run this, this is just like doesn't move. I just run this guy, right? And have a good like plot here, right? And if I go back to the system that we got like a new model, if you take a look at it, if I take a look at time, I didn't cheat here, right? And then now we are in you can, these pipelines are parameterized, so you can actually add like some parameter. And in our JupyterLab, you can just use this as if it's just a normal like Python variables, okay? And you can just save the pipeline to our system with some name, JupyterLocks. How about this? Oh, let it exist. 2. Yeah. I rehearsed, right? So that's why I let it name. So if I save this, then this like link will convert its pipeline into the Argo workflow. Okay. So if you go to the pipeline here, got a new pipeline here, right? And like the environment for this JupyterLab is actually it's like automatically captured and converted into another like Docker image. So all of your local packages and other like environment will stay. You just retain those environment, okay? So that you can run this pipeline with that environment automatically. And you can run this pipeline with like new set of parameters if you want, right? If I run this, the image is being built, doesn't work. So I made another pipeline that actually everything is already, every image was already built, right? So, I mean, you can run with different parameters, perhaps like 8 estimators, and you can run this. And this is not on a Jupyter, but actually this is run on top of the Argo workflow, right? So go to the model, that will save a model, then will be a list of models here, yeah. Then for this model, for example, if it was like trained by our pipeline, click this, and you can see what pipeline trained that model with which parameter, like this. So you have observability here. And you can create an API endpoint, also by giving some names. Sorry about that, right? And for this, you just attach the model that was trained, something like this, right? With instance type. And the just endpoint will be created. So, and I already make one for you here. So you have a like URL here and an example inputs like this. So if you go to the use call to carry out the inference, right, directly, then it works. So it's easy to like incorporate this into the web app, basically. Okay. Okay, let's go back. Where's my presentations? So, okay. So, yeah, let me finish this quickly. Okay, the future of MLOps, right? So, the John Boyd, who was American fighter pilot, actually during the Korean War, and a military strategist said that, like this famous like Boyd's law of iteration, which is like speed of iteration actually beats the quality of iteration, right? So well, as like MLOps is becoming a must-have for any kind of ML project these days, and data science and ML modeling themselves are essentially like iterative processes, right? But actually setting up a working MLOps involves integrating many components, and it's also on the iterative processes, right? So, of course, many bottlenecks still exist, mainly because we need lots of efforts from many multidisciplinary roles to complete the MLOps loop, right? So, for example, among data engineers, data scientists, MLOps engineers, software developers, domain experts, and operator, right, to name a few. So we still need to keep finding ways to strengthen the links among them, right, and improve the links to get a faster iteration and get a better MLOps. So yeah, if you want to learn more our MLOps product, please feel free to like use the QR code here. And yeah, thank you for your attention. Thanks.
Thank you. Do we have questions from the audience? Anyone? So I have one question.
Sure.
Is you mentioned earlier that you see this as a way for data scientists who don't know yet MLOps to kind of start using it.
Right.
But do you see this as an intermediate step to moving to other things, or just this is you're going to keep developing it as this should be like the core of how you do MLOps now?
Yeah, sure. At this point, like this should remain as our like one of our offering, but like we actually like our like goal for how can I say so we think that our MLOps should be like comparable with many other like great packages and services. So we are planning to just like if like some data scientists can like write like the algo workflow by themselves, we should be able to take that patient as well, because sometimes you need more flexibility than those we have provided, right? So this will still, in short, it will remain as an important component, but we also aiming at connect to other many services to make an MLOps product. Yeah.
No one has. I'll keep going. One more. I think you. So one thing is, where can we find your slides?
Mm-hmm. Sorry?
Where can we find your slides? Will you post them or share them?
Sorry, can you say that?
Your slides. Where can we find your slides if we want to look at them later? The presentation.
Okay. Yeah, sure. Yeah.
Where is it published online somewhere
or? Not yet, but yeah, we can publish it.
Cool. So my question is, what do you plan? Like, it looks to me like you've already developed a lot, and it's a really interesting system. Mm-hmm. What are you excited about next? What are next steps that you think you want to do?
Right. Yeah. So because we are not really a big company, so we are focusing on what we are doing very well. Mm-hmm. And like for the other things, for example, like something like the data like warehouse, mm-hmm. or like or experiment tracking like service, we actually keep trying to like increase the compatibility with the other services to make MLOps system very well, because like as I said, like every project have different requirements for their MLOps, so it should be support like as many as possible, that can be achieved by increasing compatibility with other services. Yeah.
Thank you. Everybody, let's thank our speakers.
Thank you very much. Yeah.